Hi, Year 12. Back for the second round. Alright, so I think I've got this now. I've been watching all my videos. This is actually only the second time I've taught this, and I never did this myself at school. So you have to understand that this is new for me too. So let's learn together. So it says here, reconsider the cut from example 10E3, part A. Show that this is the minimum cut without considering every cut possible. Well, you can probably do that by looking at the flow. So what I mean by flow is if you follow the arrow direction, that's the flow. Okay? So if you have a look here, only say 1 litre can flow down here. So that means only 1 litre of that 1 litre can flow down here too. And if 2 litres can flow down here, then when you get to this point, one of the litres can go that way, the other litre can go that way. So in effect, once that one comes around, this one, when it comes around, that's another one, because that one's got a capacity of 2. So, okay, the minimum cut, yeah, I don't know, I actually just find, well, oh really, let me get rid of all that mush. The easiest way to find the minimum cut also is to look at the smallest numbers, okay, and have a look. That's probably the best way to do it. So here you've got a 1 and a 2, they're pretty small. Here you've got a 1 and a 2, that's a 3, so you probably wouldn't even bother looking at that at all. So that's probably the easiest way to do it. Look for the smaller numbers. Alright, 10E5, finding the maximum flow. So what I was just doing a minute ago, you have to do that here as well. Now you have to realise you've got to follow the route. Now the flow of water is dependent on the smallest pipe possible, isn't it? So if this one goes 110, 90 and 70, well then the smallest flow on this particular pipe, the red pipe, can only be that smallest number, 70. So I can't fit 110 litres down a 70 litre pipe, alright, at the same speed and at the same time. Obviously it'll go slower. So that would be my maximum flow for that top red route. If I change my colours, if I go the middle route, this one here, I can go 30, but then I can only go to 20. So if I'm trying to get anything down that particular route, I can only go as fast as the smallest number. And then if I pick another different colour, a lovely purple, if I try and go down that route, then again the smallest number, doesn't matter which one I pick, but it's 60. Okay, so find a flow of 150 units. Alright, can you find a flow of 150? 70 plus 60 plus 20. So that's your flow of 150. Prove that this flow is the maximum possible. Well, if you got rid of all of those lovely little diagrams and decided to do cut as well, you could cut here. But remember, the easiest way to figure out the cut is go through the smallest numbers. Okay, I've got a 30 there, but really that one's still smaller than 30, isn't it? And I've got a 60 and a 70. So if I did a cut there, that would actually be the smallest cut. So when you're finding, remember, maximum flow equals minimum cut. So if you can find the minimum cut, you've found the maximum flow. All right? They mean and they equal exactly the same thing of each other. So if you get minimum cut and it makes sense in your head, always use that to work out maximum flow. It's just the same concept, okay? All right, so then I asked you to have a go at question 5 and 6. So I drew it very crudely here. And question 5 said, find the capacity of the cut. So I was watching the Mr. Bodger's video, and I think it was the 4th one out of the 5 for 10G. And he actually explained this really well. And he said what you've got to do is you've got to realise that on this red line, there is a source side of the red line, that's this side, and there is a sink side. So the red line cuts it in half. And you can't have anything flowing from the sink side back to the source side, all right? You can't count it. And the guy on Maths Online, he did this quite well as well. So what we want to do is we want to find just the green arrows across the red line, just the green arrows across the red line. Okay, so I don't want this 3 here. I don't want that one. Okay, don't include that one. I'll do a different colour. I'll do it in red. So I'm going to include this one here. I'm going to include this one here. Alright, now this one here, I'll do it in purple. This one here has already been cut off by this flow here. So if it's already cut over here, you can't include it. So I don't include that 4. Okay, I'll change my pen to red. However, this one here, okay, you can go from the source and it hits there. So I'm going to include that one. Now, also again, I could go from the source here to this dot. So any of these ones, I must also count because they're going from the source side to the sink side. So that means to work out the capacity, I've got to add the 1, 4, 4, 6, and 6, and then the 5 and the 1, and that makes 27. Ooey, 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 hey? All right, let me get rid of some of those red lines. I'll pause it there just in case you want to take a photo or anything, just to keep that one. You can always rewind anyway. So if I get rid of some of those, sorry, I'll put that back in a sec. Come on. Come on. Alright, so now I'm going to do, I'll just leave that in for the moment. So that equaled 27. The question 6 uses the same diagram. So question 6 says the flow along each edge is given in red above the capacity of the edge in black. What is the flow capacity specified below? Oh, let me have a quick look. So let's go back. The answer for 6 is 12. Let's see if we can work that out. So this is what we do. So I'll just do it in red. If we follow this one here, it's got a flow of 5. Would you agree? Okay, so then we've got to work out what pipe flows out of there. So at the moment, I've got these 2 pipes flowing out of there. Okay, now I've also got these pipes going this way, so it can get a bit tricky. So this one's got an amount of 3. Okay, so what happens is, if I've got 3 litres going down that way, I can give that 3 litres to any of these 3 pipes, because they're all coming out of that particular vertex. Now, in your diagram, you can give it to the 2, the 1, or the 3, it doesn't matter, but they've given it to this one. So if they say, right, my 3 litres is going to flow down there, then that means there's no litres left. So that means we're going to give a big fat 0 to these 2. So that's where those zeros came from. And if I follow this one here, that means I've got 4 litres. I can go out that way or that way. Now on our diagram, they've given all those 4 litres to just this guy here. So that means there's none left for this one. So that's why he's got a 0 on him. And then down here, I've got my 5. So I've broken up that 5. Now this one's got 0, so I can't add to the 5. So I've given this guy down here, I've given that pipe 4, and there's 1 left over, so I've given it to that pipe. So that's how they're working out these flows, just in case you're a bit confused, because I was, about all these little diagrams. And then you've got to kind of follow the arrows and hope for the best. So when you follow this one down the bottom, that means when I get to this dot, I should have 4 litres ready to go, right? Okay, so when I follow again, I'm going down from a bottom pipe. I've got 1 here. So that means I can have 1 flowing through this particular one, and then I've got a 4 here, and I've also got a 3 here. So that means I've got 4, 3, and 1 makes 8. Okay, so I've got 8 litres to give away from this point. So you'll notice on their diagram, they've given 4 of the litres to this line. They've given 3 of the litres to this line, and they've given 1 of the litres to this line. Okay, now because they've given it out to those ones, there's none left for this fella going straight up, so he turns into a big fat 0. So the capacity of this little red dot at the top here, the 2 arrows leading into it, is actually 0. So this one turns out to have a flow of 0 coming back down this way. Okay, this one's got a flow of 4 going into it, so that means I can give that 4 to this 7 down here, and I can give 3 to this one here, and my 5 here can add up this one, the 4 and the 1, and that also makes 5. So if I add, I'm assuming, these three numbers here, I get 12. Now, I don't know about you, I like minimum cut so much better. I think it's much easier. So really, I would suggest you remember minimum cut, because flow, as you can see, is amazingly crazy. Now, you could have separated any of those numbers you wanted, but if you've got too much going through a particular vertex, you're going to have to backtrack and try and spread it out differently. So just watch the way you spread things out. All right, so question 8 is asking us, what is the maximum flow in this diagram? Now, I like minimum cut, so that's what I try and use. So I'm just going to go work backwards. 8 says the answer is 6. So let's see if we can work this out. Maximum flow equals minimum cut. So you want to look for your smallest numbers. I've got a 1 here. So on this particular route, 1 is the smallest. On this particular route, 3 is the smallest. And on this particular route, 2 is the smallest. So I'm going to put my cut going through those 3 smallest. Okay, and if I look at my answer for 8 is 6. So the maximum flow is always going to be the smallest number on every route. So my minimum cut will equal my maximum flow, which is 6. All right, this one was a fun one. Shopping centre car park. All right, what's the maximum flow from the main road to the car park? So again, minimum cut is the easiest. So look, again, sometimes doing it here at the beginning and at the end is often the easiest. Now, if you look at your little numbers, you'll notice you've got a 3 in here, a 4, you've got a 2, but you've got to make heaps of cuts to make those work. If you added the 5, the 3, the 4, the 2, and then the other 4 down the bottom, so if the cut was through there, for example, that adds up to 5, 8, 9, 10. That adds up to 18. If you add up this one over here, 5, 7, and 6, that's 12 plus 6, that's 18. But if you add up that one over there, you get, I'll get rid of one of those, that's too much. 7 and 6 is 13, plus 4, well, that one is 17. So the maximum flow is the minimum cut. So in this case, it's 17. It says find a cut with the same capacity as your flow from part A. So is there another one? All right, let me have a quick look at the answers to make sure I'm doing this right. So SB, yep, that's my cut. SC, yep, that's my cut. And SI. All right. Find a cut with the same capacity as your flow. Does this make your cut minimal? Yes, it does. So that's my minimum cut. You could have gone through that one too if you wanted, because both of them fall. You actually probably could have gone through that one as well. So any cuts going through there would also give you a capacity of 17. What edges are saturated? Well, I think most of them are saturated. So if you follow it all the way around here, 4, 4, 4. So then you give, I'll make this a bit bigger. Beg your pardon, sorry about that. You make 4 coming out of this little node here. 6 coming down, if I give 4 litres to this one, for example, and 2 cars to that one, when this one gets over to here, 2 plus 4 makes 6, so that means this edge is also saturated. If I come along 7 here, if I give this one the 3, that leaves me only with 4 for that particular edge there. And if I bring this one down with the 3 and the 4, then that one is 7, as that edge says. Okay, and if I bring this one along, that one's not saturated. So BG is not saturated. BG not. And then probably following BG is this one coming down here, G to T. It's also 5, so the flow can only continue to be 4, so it's also not saturated. So everything but. But BG and what was that last one? GT. Sorry about that. Okay, so those 2 edges that are not coloured in, they're the 2 that are not saturated at the top there. Increase the capacity of one edge so that every edge is saturated. Okay, I'll do that one in purple. Well, we know that we only need to do something with these two, and they're both just 1 down, aren't they? So if I increase that one by 1 to an 8, that's going to add 1 to each of these guys, which will make them 5. So if I change SB to 8, then all edges will be saturated. Okay, I hope that helps. I'm going to do some more. Let me know if you need any help, please.